portable cords. The reason why we are studying this matter is that, as I said in the previous 8 o'clock session today, if you are just a regular consumer that goes to any kind of a hardware store to buy a tea kettle or a toaster or a vacuum cleaner or a TV or a radio receiver, anything that requires power, you are not required to have any electrical knowledge. Yes, you could be a baker, or you could be a seamstress, or you could be anyone in this society doing anything else, having no knowledge absolutely whatsoever about electricity, and you should be able to buy equipment and plug it in. This is how things are being designed by the engineers that design things for us. Then you can just plug things in and use it. It's a plug and play. You don't have to worry about the gauge of the wiring. You don't have to worry about the ampacity of the receptacle in the kitchen. You're supposed to use it. And sometimes you're going to have little instruction manual on how you should set things up or whatnot, depending on how complicated the equipment is. But this is a different class. This is actually a class that has something to do with electronics and electricity. And depending on what jobs you're going to land, you might be required to use this knowledge. And if you don't use this knowledge, and if you don't have this knowledge, then, well, you might be a little bit uncomfortable, and your boss might find you a little bit less employable. So portable cords, let's just get some definitions. A portable cord, which is also known as a flexible cord, or it's also known as extension cord, is a cable with multiple conductors. Well, things make sense. It's a cable that has multiple conductors. We have dealt so far with a NMD 90 cable. It's a cable. A cable is, it's an enclosed, it's an enclosed entity that has other cables in it. It's a cable is made out of multiple conductors. Well, a cable can be made out of a single conductor, but there's a conductor, it's insulated and it's jacketed, and the copper is a copper. You can have stranded conductor, or you can have a solid core conductor, but it's made out of copper for the most part. Sometimes you have conductors made out of different metals such as aluminum, but what makes a cable and the cable that is designed to be used in different circumstances is actually how the cable is packaged, which is the surroundings, which is the insulation, which is the jacketing. Right, so that's what makes cables different one from another. As far as the conductivity, the metal copper conducts current the way it does. Right? So let's see how things are being packaged and for what purpose. Okay, again, portable cord, which is known as a flexible cord, is a cable with multiple conductors, makes sense, used in applications required flexibility. Portable cord is used in applications requiring flexibility. Now, when I'm saying that is, the portable cords or extension cords should not be installed as a permanent installation. And what do I mean by that? Let's say you are in a classroom or some sort of a conference room, and you're required to do some presentations or teleconferencing or whatnot. That requires somebody to roll in something that's called an AV card, on which there is going to be a TV set or a monitor and some equipment required for you to conduct, let's say, teleconferencing with somebody in Tokyo, for example. All right. So then that will be a temporary setup, right? And so it's not a permanent installation. It's a temporary setup. So things are being rolled in, and the portable cord is used to provide power for that. It's used as a service cable, and service cable is a cable that provides power, as opposed to maybe a signal type of a cable, which would be, for example, an antenna cable, or microphone cable, or a speaker cable. These are not service cables. These are signal type of cables. And the service cables are providing power. So the overhead wires that go from the hydro pole that is down the street, and they extend overhead, and they go to that point of entry that usually sticks like a big stick from the roof, and things are being connected there. That's a service cable that provides power for the whole house. And extension cord, or a portable cord, that provides the power for that rolled in AV station or AV card with TV on it. That is also a service cable, because it provides the power to that thing. So this is a temporary setup. But it would not be a good idea. You should not install, like, for example, there is a, let's say, retail business. And the retail business has a security system in terms of surveillance cameras. Pretty much all the stores have security cameras installed. And sometimes there is like a viewing monitor for people to walk in. As they walk in, they can see that there's a monitor. So it's just some other kind of like a thing to deteriorate people from stealing, because yes, there is a security video security system in place, and yeah, you're walking in and you're on camera, so smile, right? And so what happens is that there's that monitor hanging from the ceiling, on this whatever mount it is, and of course power has to be provided to that monitor. So and that's considered a permanent installation. So it's not a good idea to use a portable cord. It you should not use we shouldn't use the portable cord for that application. There should be a proper power provided to location, and that monitor should be plugged in to that power that is provided, in terms of like a duplex receptacle, for example. Okay, so that's what I mean. So a cable with multiple conductors used in applications required flexibility. Another example of flexibility is, let's say it's a car shop, and people have, the mechanics would have different diagnostic equipment. They would have different portable lights that they use. They would have different lifts or whatnot, or um, well, drills, hand tools, power tools that require to be plugged in. So portable cords are being used for that, or a vacuum cleaner. Yes, portable cord is used for vacuum cleaner, so it's not a temporary installation. Okay, the cord can be used to provide power for a range of applications, such as small hand tools, movable equipment, and there's a phone ringing there. I'm just gonna wait for that thing, somebody to pick up the phone. Da-ding-da-da. Okay, I think somebody picked it up. All right, so cord can be used to provide power for a range of applications, such as small hand tools, movable equipment, power extensions, or home appliances. And here are some examples of portable cords. Here is a portable cord that you can go and buy it in hardware store. Here's another one that's attached to a power bar. Notice there's that plug here. That's a European 220 volts. That's what they use in Europe. I just noticed that. And then there's another extension, small extension cord that you can use for your table lamp or something like that. So that's fine. All right. So these are extension. These are the examples of, we're talking about portable cords. But why is it that we spend time actually learning um, mm, about something like this? All right. There's a question here. I'm going to stop for a sec before I forget to answer. How much time will we have to complete quizzes? Okay, my quizzes are designed to have no time limit. You can take 5 minutes to do it if you know all the answers quickly, or you can take 5 hours to do that. The only thing that you could get kicked out of the system is that if your computer or is the FOL is set up to kick you out of the system due to inactivity. So if you leave it open for too long, then you might get terminated when it comes to connection. Right? Um, so that it will be all explained to you when yeah. So there's no time limit. I hope it helps. I hope I answered the question. All right, so the cord can be used to provide power over movable equipment, power extension. So here we got the examples. Okay, let's keep going with the slides, shall we? All right, portable cords. Portable cords might be used in commercial, industrial, or residential applications. Well, as future electricians or people that will have to do with some sort of installations. It could be also data installations, as what I did for about 30 years. Yes, you're dealing with portable cords a lot, and you should be able to, in commercial, in industrial application, you should know which cords you should use and which cords you shouldn't use, and we'll get to that. All right, so they work well on job sites where resistance, and that's where all this fun begins. Here's where you're getting the meat and potatoes of this. They work well on job sites where resistance to oil, chemicals, and abrasion. Abrasion is basically physical abuse, if you can say that. Okay, so they work well on job sites where resistance to oil, chemicals, and abrasion is important. They have to be, those portable cords have to be able to withstand whatever is thrown at them and not get damaged. Right? So their construction enables them to perform well in extreme environments, both heat and cold, outside or inside. Additionally, some portable cords can be weather or water resistance and water submersible. This here, this whole text here, it doesn't mean that all the portable cords are resistant to all the conditions. Sometimes some of them are supposed to be used in, they are designed to be used in certain conditions, and some other portable cords are designed to be used in some other conditions. Okay, so that's what we're looking at this thing. And what we have here on the picture, we have the whole, this is an example of a cable. Here's the outer jacket, and it encloses multiple conductors. Here is a outer jacket, and there would be some bushing inside or whatnot, depending on what this thing is designed for. And they have multiple conductors. So what can we say about this one here? This looks like a power cord or service cable. Well, remember on the labs when we were talking about the bonding, the difference between bonding and grounding. If you don't know what the difference is between bonding and grounding, you should by now. But if you don't, if you're not clarified, ask us during the labs. Or sometimes you can send me an email. So the bonding or grounding wire can be either a bare copper or green jacketed wire conductor. So over here we can tell, here is a bonding wire or grounding. Here's a bonding wire. Here's a bonding wire or grounding. This one doesn't have a bonding or grounding wire. All right, so can we tell where the neutrals are? Yeah, okay, so here's white, that's neutral. Here's white, that's neutral. Here's white, that's neutral. Can we have the hot? Can we identify the hot conductors? Okay, here's the black, here's hot. There's a black conductor, here's hot, here's hot, here's hot. And there's also red. Well, this is hot, red is hot, and red is hot. Oh, this one does just have neutral and hot, and it doesn't have a bonding conductor. Right? So different cables are used in different conditions. Now, because they are portable cables, then there's a 99.9 or maybe 101% you're going to have a chance of that being not a solid cord, not a solid core conductors. These will be stranded conductors because stranded conductors provide more flexibility. You can move them around, you can flex them, you can bend them, you can basically route them temporarily and take them off and put them on. And the stranded conductors are basically designed so they could be moved around. If they were solid core, they would not last as long as the stranded conductors would. Right? So what can we tell here? Here's a um, probably 14 gauge, like that what looks to me. This one here will be 14 too. Why is it 14 too? It has 3 conductors. We're talking about current carrying conductors. It's just a review from the previous. Some of that stuff could be on a test or quiz. Hint, hint. Right? As long as you know that, I don't care about giving you hints. I want you to. My objective is to give you as much information and knowledge as possible. So once you leave that school and you are on your own, looking for a job or find a job, and you want to keep that job and be good at it, I'm trying to give you as much as I possibly can, so you're most comfortable in that environment. All right, so let's go. Next slide here. Now, I'm going to make your head spin for a second, and then I'm going to make your head unspin with the next slide. All right, so let's see, portable cords designations, right? Common types of the portable cords include SJT, SVT, SEOW, SJ, SJOW, SO, and SOW, right? Now surpassed by the SOOW type. All right, so now you know. Okay, is your head spinning yet? Good. All right. Okay, so the letters correspond to a characteristic of the insulation and jacket applied to the cable. Remember, as I was saying, the copper is a copper. It could be stranded conductor, or it could be solid core conductor. It conducts current, and depending on what gauge it is, it would have certain ampacity, which is the current carrying ability. So if it's a thicker cable, it can carry more current. If it's a thinner cable, it can carry not as much current as the other one. Get it? Get it. Okay. Now, when we are talking about the designations for the portable cords, we also have to consider what type of voltage they can handle. So one is the current. So we get that by looking at what gauge it is, and depending on the gauge of the conductor, then you can tell what the ampacity of the conductor is. Then what type of jacketing and insulation is being used to enclose those copper conductors, then we can talk about how much voltage that insulation can handle before it breaks down. All right, so example here, SOW. And I'm just going to throw this at you for now. And with the next slide, I'm going to explain what's going on. So SOOW and SEOOW. We have those letter designations to describe the purpose and the application of specific cables. All right, so SOW, this would be rubber, durable, greater dielectric strength. What's a dielectric? Dielectric is another word for insulator, as opposed to conductor. Conductor conducts, insulator insulates, prevents from conducting. And sometimes we have situations that we want the current to flow, and sometimes we have situations that we want the current to not flow, so it can flow the way we want to, not the way it wants to. Right? So dielectric is another way to describe a insulator. So it has greater dielectric strength, higher tear resistance, well, because it's made of rubber, right? And let's say the temperatures, excuse me, maximum conditions 90 degrees Celsius, and minimum temperature, it can go as low as minus 40 degrees Celsius and still be intact up to specifications. Now let's look at the SEOOW. It's a thermoplastic PVC. Well, what's a thermoplastic? A thermoplastic material is a material, now listen to this, that can be subjected to heat, and it could be cooled down multiple times, and it is going to retain its properties. It's not going to change its structure. What can we do we know anything that changes its structure after being heated? Well, let's say pizza dough, right? It's nice and flexible and moldable, but you subject that to certain type of heat and it solidifies and it becomes something else. It doesn't come back to the previous state after being cooled down. So that would be not a thermoplastic material. Pizza dough is not thermoplastic. If it is, don't eat it. Right? So thermoplastic elastomer, right? Or elastomer. What is that? That's any type of elastic material. So rubber could be elastomer. The vacuum cleaner hose that perforated that looks like a throat pipe, it's flexible and it's elastic. You can stretch it a bit. Yes, you know, my stretchy pants that I'm wearing, are they elastomer? I don't know, but they stretch. All right, so that's a thermoplastic. That means it is it can be heated and cooled down and it will not change its structure. So that's thermoplastic material. And then there's elastomer or elastomer. Then that means it's flexible. It's elastic. Then again, for the SEOOW that we're talking about, maximum, you see, you can withstand greater temperatures when you go up as opposed to the other one, SOOW. 105 degrees Celsius as far as that, and then it could go as down as as low as minus 50 degrees Celsius. Okay, so now when I have thrown this at you, let's see what they mean. Okay, so when you see a designation like S on the cable, that means it's a severe service cord. Remember when we were talking about service cord? A service cord or a service cable is a cable that is supposed to provide, it is used to provide power as opposed to a microphone cable that is providing signal. So you see S and you see SJ sometimes. All right. The S is considered a severe service cord. What makes it a severe? It can go up to 600 volts. That insulation right here between those two pieces of copper or those three pieces of copper, if the difference of potentials or the electric pressure or the voltage is 600 volts, it still should not pass the current. It's rated for 600. If it's more, then, well, we're not allowed to install that. You know? Okay, so it's a severe service cord. That means 600 volts. And I don't know why they put that, but also is good for 277 volts. If you see the designation on the cable that says 277 or 480 volts or 480 volts, that's it, then you can use that cable with the designation of S because, of course, yes, it can handle up to 600 volts. So if you have 270 volts or 480 volts, yeah, it's less than 600. So yeah, the cable is good for that application. All right, so might be utilized in place of SJ in extra severe service. So let's say, yeah, can we, if you have a SJ cord and it got damaged because maybe somebody hit it with something or ripped with something, and all you have is one that says S, can you use that instead of SJ? Yes, you can, because SJ stands for junior. That J stands for junior, so it's a SJ, but it says junior severe service, and it's only up to 300 volts. So can you replace the SJ with the S designation cord if you have it? Yes, you can. But can you replace the one that just only has S with the SJ? Well, not so much, because one is supposed to handle up to 600 volts. It's rated for 600 volts. And the other one is rated for 300 volts. right? And then there's also, if you see those, that this one is good. If you see 120 or 122.08 or 122.40 or whatever those designations are, as long as it's less than 300 volts. You cannot use it if the cable designation is for 277 or 480 volts. Then you should not use that, because it's only up to 300, and that 480 cannot exceed those specifications. So then if you want to use a cable in those applications when there's 480 volts to be carried, then you should use the one that says just a severe service cord, not junior severe service cord. And again, as a reminder, service means this cord is carrying power. All right, okay. So then you're going to see the designation of T. That means it's a thermoplastic. And what's thermoplastic? Well, a material, which we're talking about the jacketing or insulating, whatever is surrounding that copper. Copper is not changed. Copper is copper. So thermoplastic means, again, that the material or the insulation or whatever surrounds that copper, it makes up a cable. We can heat it and cool it down, heat it and cool it down, and it's not going to lose its physical properties. It's still going to be as stretchy as it is. It's still going to have that structural integrity as it had before it was heated and cooled down, as opposed to a pizza dough. It stays that way once you heat it, right? Then when it has a heat, and then there's a heat resistance, and there's that high heat resistance, and there are some numbers that are associated with that, depending on what the specifications are. And then there is the N, that it's supposed to have nylon outer jacket material. Sometimes you are supposed to have that, depending on the circumstances. All right. And then there is the E, that it says elastomer. It's a, well, there's another description, a thermoplastic that looks and feels like rubber. Okay. So elastometer, the elastomer, elastomer. Okay, it's a material that is elastic. And then we have the O and double O. Right? If you see O, that means, oh, it's oil resistant outer jacket material. And if you see double O, uh-oh, then it's oil resistant outer jacket and oil resistant insulation. So it's like double insulated with oil resistant materials. So not only the jacket, the outer jacket, but the insulation is supposed to have, is supposed to be oil resistance. So what do we see here? Here. Okay. Here is the outer jacket. And here is the insulation. Sometimes when it's O, it's a single O designation, then it's okay if just the outer jacket is oil resistant. And when it's a double O, so this has to be oil resistant, and the insulation also has to be oil resistant. Why do we need oil resistant cables? Well, let's say you're working in a car shop where you need to, when you are using a bunch of extension cables or portable cords, and those cords are being on the floor, they touch everything. And of course, in the car shop, everything is covered with some sort of like goo that's oily, and some other chemicals that are being used, and everything is there on the walls, on the floor. You can clean it up as much as you want. You can only clean it up, but whatever is there is going to come in touch, in contact with some of those chemicals and oils. And what happens if the cable is not designed to handle that? You get your hands dirty with oil, you just go and wash them. And if something is happening to your hands because some chemicals, you're going to feel it and you're going to seek help or whatnot. The cable doesn't. The cable is not alive. The cable doesn't feel, and it's not going to communicate with you that, look, I got an itch on my skin. No, the cable is just going to break down. And when the cable breaks down, then it can hurt you, right? So there it is. Then there's a designation of the V. And here is the, what does it say? V stands for vacuum. typically used with the vacuum cleaners and other portable cleaning equipment. Why do we need to have that? Well, when it comes to, let's say, custodial work or any type of commercial cleaning applications, again, those cords are being are being unwound and wound again, and over and over again, and then they come in contact with specific cleaning chemicals and combined with dust and whatnot. So there's got to be some extra uh, resistance that has to be provided so those cables can withstand that constantly being subjected to that type of abuse. Okay. Now, then there is the W, or sometimes you can CSA, weather and water resistant, approved for indoor and outdoor use. So if you see this kind of a cord right here, this one right here, that cord, a lot of people use that for the Christmas lights, to connect the Christmas lights on around the roof. Well, check it if it has the W in there, and there would be those designation strips right here. Read those. If it's not approved, then you should not use it. But a lot of people do, and well, sometimes you can hear those fire trucks. I'm not saying that it's exactly because of that all the time, but it's a possibility. Uh, so we have that. Now, how would you see those? Sometimes you're going to see designations like that on the cable, printed right, like it will be stamped right on the cable itself. So you just take the cord and read it, see whether, and sometimes there will be designation strips like stickers, the ones that you saw a couple of seconds ago. And you're going to see things like this, right? That's where the letters are. Where would you see that? You would see that on the cord itself or in the paperwork that's included with that cord. Or you can see that in documentation that is provided with the machinery that you're supposed to install. If you're just a consumer and you go to the local hardware store and buy a toaster, you don't care about that because it's made in certain way that you don't have to know electricity or any of that stuff, because also the receptacles in the kitchen are made in certain way that yes, you should be able to plug it in and not worrying about that you're breaking any codes or rules and regulations. But when you are working, let's say, especially in the industrial environment, and there is a new machine that the company has bought, and your job is to make sure that it works, it doesn't have that power cord like your computer does. It doesn't have that power supply like your phone charger. It will come packaged in bunch of wooden crates and whatnot, and it will have to be put together, and it will have to be installed and connected as it should be. And sometimes you're going to have the requirements in the paperwork that come with the equipment, and you're going to see also this kind of stuff. So basically you have to match that or exceed. Right, so let's analyze this here. Analyze this. I think there was a movie like that. All right, so S, remember? And as soon as you see S, then you're looking, is there J after that? All right, so one is 600 volts. If there is no J, J means junior, right? And S means severe service cord, which means 600 volts. It should be able to handle 600 volts. But is there J? If there's J after that, that means it's a junior severe service cord, which means no, 600, no, 300 only. Okay, so that means this cable here is designated to not exceed the usage where 300 volts is present. What's the next one here? We have the E. Well, it's this thermoplastic polymer. Um, thermoplastic polymer. Okay, polymer is from plastic. So thermoplastic, artificial kind of a matter. So thermoplastic. So if you see that, that means that if it's subjected to severe temperature changes, it's not going to alter its physical properties, its physical structure is going to stay as it is. Right? Is it thermoplastic rubber? No. It is supposed to be just the thermoplastic polymer. All right. Now we have the next, we have the O's. We see the O. Well, when you see O, that means that we're dealing with some resistance to oil. It should withstand in being oily environment, right? So, okay. So then when we see O, do we see another O or not? So the first one says, okay, this is just outer jacket that is supposed to be oil resistant. Okay, but well, we see another O here. That means not only the outer jacket is supposed to be oil resistant, but the also the insulation inside the surrounding the individual conductors, that is also supposed to be, so it's double oil kind of insulated. Right? All right. All right. And is it not oil resistant? No, this cable is not oil resistant. It is oil resistant. So that's what it means here. Then we see the W, right? Which means it's weather resistant, depending where this thing is printed. So here's a couple of notes. In Canada, E becomes T. Well, that's basically, I don't know, normally, if you see something written in the States, then you just substitute the T's with the E's. So if it's like the end, that you would say E and. No, just kidding. All right, so there's different type of designations. So in Canada, you're going to see the T with the type, other two other letters. For example, SG, So that means basically T is just like the E. Okay? So here's the example, and then the WA prior to, and there's some different regulations. That will be the older cables that will be labeled like WA, right, instead of just W. Okay, and so now we have analyzed this. We know what this cable is supposed to be. Um, can a chord have just say 2 or 3 letters? You know what? Just I would say next time you're at the hardware store, like a big, like I say, Home Depot, Canadian Tire, Lowe's, Rona, or whatnot, just take a look at some of the bulk cables and see what's printed on them. Right? Yes, you don't have to have all of those. It's not like a digital readout that you have to have that. No, you can have less letters depending on the designations. Okay. All right, so now I'm going to leave you with this, using this chart below, because there's some more explanations right here. All right. Define the following cable types, and I might ask you some of the, I'll throw some letters at you at the test or quiz and see if you can tell me about the cable. So using the chart below, define the following cable types: SEOW or SOOW. So just go look at those letters, and then there's some other letters here. See, like, look, there's 3 letters. There you go. Um, so just look at some of that stuff. And this is the thing that if you don't, like years from now, if you don't keep these nodes, that's okay. But at least you are conscious of the decisions that you have to make when you're looking for a portable cord. If someone is going to give you the task of supplying a certain type of portable cord, and they're going to say, hey, Joe, um, can you provide an extension cord for Gary there? He's working on some machine. So then you're not going to just go to a dollar store or something and say, do you have the extension cords? What's the cheapest one? Okay, that's going to be good enough. Do you have them? Do you have extension cords? Can we have 5? You're going to have to do a little bit of investigation. And now you know, at least you know where to look and how to research the topic. So when you're asked to perform task of providing a portable code for a certain application, you're going to ask a little bit, you're going to ask some questions. So where is going to be used, what's the voltage, what's the severity of that, and things like that. So is it outside or is it inside? Because the person who is asking you for that, they not necessarily have to know. It could be your boss, that they're good business people, but that's why they hire you, so you know that stuff, so their company doesn't get burned down. All right. Okay, so we'll just go through that, and we're going to review some of that next time we see each other, um, just so it stays with us. And that's pretty much it for today's lesson. If there are any questions that you guys have, by all means, shoot me an email right now. But I'm going to leave you with this, so you can have some time to go to your next class or do whatever you have to do. Okay. Okay. All right. Have a great weekend. Enjoy it. And I will see you next week or whenever I get to see you. All right. Thank you very much. Have a good one, guys. And there's dog barking in the background.